Hello everyone, welcome to my channel Chemistry Made Simple for NEET. So today, just for a change, many of the students had asked to do some important topics and concepts from physics because they are finding it a little bit confused and difficult. So we are planning to do some important units from physics as well, and we'll be also uploading some easy tricks to solve problems in physics starting from today. So regularly every day we are uploading 2 to 3 videos. So all of you just press your bell icon so that you can get the notifications immediately when we post new videos. So today we are going to do the topic capacitors and capacitance, which is very important for NEET physics. Many questions come from this usually, and we'll be doing some important topics from this. And first of all, we should know what is meant by a capacitor. This particular topic comes under electrostatics in physics. So capacitor is actually a two-terminal electrical device which has the capacity to store energy as electric charge. So this electric device can store energy in it in the form of electric charge. For that, it has got two conductors which are separated by a distance, and the space between the conductors can be filled with vacuum or any insulating material known as dielectric. And the ability of a capacitor to store charges is called the capacitance. This is the symbolic representation of a capacitor. This is the capacitor, and here we are having the battery with positive and negative terminal connected to it. And you know, capacitors normally store energy by holding apart pairs of opposite charges. And simplest representation of a capacitor is a parallel plate. So it's nothing, just two metal plates with a gap in between them. And also the capacitors are of different types. They are manufactured in many forms, styles, lengths, and different materials and all that. And this most basic representation is the parallel plate capacitor. And the parallel plate capacitor, it's very simple arrangement. Suppose you connect a DC voltage across the capacitor. When one plate is connected to a positive end and another to a negative end, and if you apply the potential of a battery across the capacitor, what happens? The plate connected to the positive end, that is plate 1, and another plate is connected to the negative end, that is plate 2. And if potential of the battery is applied across the capacitor, plate 1 becomes positive and plate 2 becomes negative, and at the steady state condition, current tries to flow through the capacitor from positive plate to the negative plate, but unstable, normally it is unable to flow due to the separation of this with an insulating material. Okay, and normally an electrical field appears across the capacitor. The positive plate will accumulate positive charge from the battery, and the negative plate 2 will gather negative charges from the battery. After some point, the capacitor will hold the maximum amount of charge as per its capacitance with respect to voltage, and this time span is called the charging time of the capacitor. And what happens when you remove the battery? Then the two plates hold a negative and positive charge for a certain time, and the capacitor at that time will act as a source of electrical energy. Now, normally you should remember one point, that capacitance is directly proportional to the area of cross section and inversely proportional to the distance between the plates. Suppose the area of cross section of the capacitor plates, if you increase it, then what will happen? More charges can be distributed for the same potential. There won't be change in the potential difference, but more charges can be distributed, and therefore the capacitance will increase. And what is the capacitance of a parallel plate capacitor? This is a parallel plate capacitor with two parallel plates. You can see that plus Q, here plus charge, this is area, and minus Q, and the cross sectional area is A, and it is separated by a distance D. You can see the figure here. Then suppose the distance d between the two plates, if you reduce them, then the potential difference between, what is the potential difference? E into d. See this E, okay, E into d is the potential difference. So V will be equal to ED, that will decrease with E constant. So as a result, what happens? The voltage difference between the battery terminals will increase. As a result of that, extra flow charges will flow to the plates from the battery till what time the voltage on the capacitor is equal to the battery's terminal voltage. So till that point of time, the flow of charge to the plates from the battery will happen. Suppose you increase the distance, then the capacitor voltage increases and becomes greater than the battery voltage. Very easy, you can remember this. So the charges flow from capacitor plates to the battery till both the voltages are equal. Hope this concept is clear to you. Now, what is the total charge stored in the capacitor? It's always 0, Q minus Q. Suppose we say that the capacitor store charges, that means the amount of charge that can be stored in any one of the plates, only one of the plates. Okay, nowadays we are having capacitors in various shapes like cylindrical, disc and different types, tantalum, ceramic, electrolytic, etc. And the capacitors are very largely used in various kinds of electronic circuits. So many electronic circuits are there in field nowadays. So all of them use capacitors. It's an integral or very crucial part of a circuit. And you can see the formula here. It's very useful for doing sums. C is equal to Q by V. Capacitance is equal to Q charge by V volt. SI unit is Coulomb per volt or Farad in honor of Michael Faraday. Farad is a large unit of capacitance. So normally capacitors are available in the range of microfarad. See the relation 1 mu f is equal to 10 raised to minus 6 farad to picofarad, that is 1 picofarad is equal to 10 raised to minus 12 farad. Normally you represent a capacitor by this symbol, either this or this. See, two lines like this, T, inverted T. Okay, clear? Okay, now something known as fringing fields we have to learn. See here, plus and minus plate. You can see all these are straight, but here see starts little bit of curving. Here also now it is curving more and more. See here like this. So what is my fringing field? That I will explain to you, and before that you have got one more, schematic diagram of a parallel plate. Two plates are there, plus Q and minus Q, and this is a diagram for parallel plate capacitor. Now what happens is that when a capacitor is connected to a battery of potential difference V, electrons are transferred from one plate to other by battery, so that one plate is negatively charged Q minus Q and other plate is positively charged plus Q. And normally the potential difference between the plates is equal to the battery's terminal voltage. Remember, this relation is useful to you regarding the concepts. Potential difference between the plate is equal to the battery's terminal voltage. Suppose if the battery voltage is increased, amount of charges stored in the plates also will increase. Okay, now you are having, see for your reference, have included various types of capacitor diagrams. Different types are there. Okay, now electric field between two infinite parallel plates is uniform, as we said before. Between two infinite parallel plates, electric field is uniform. It is given by the formula E is equal to sigma by epsilon 0. Sigma is the surface charge density on the plates. Now sigma is equal to Q by A, or you can also use the relation Q by A E0. Okay, suppose if the separation distance is very small than the size of the plate, d square is small to the size of the plate, then the result is used for even finite sized parallel plate capacitor. Remember this, E is equal to epsilon by sigma by epsilon 0. Okay, this relation is very important. Remember the formula as well. Now we were talking about the fringing field. What is it? While finding out the expression for capacitance of parallel plate capacitor, the expression of the electric field for infinite plates, we use it normally. For finite size plates, electric charge field, it's not uniform between the plates. No, it will be not consistent, not uniform. So both edges, the electric field is bent outwards, as I showed in the diagram before. Capacitor, normally we use it to store electric charge and electrical energy. What are the uses? What is its function? And always it is having two plates which is separated by some distance, and capacitors are mostly used in many electronic circuits, and they find applications in many areas of science and technology. And simple capacitor has two parallel metal plates which is separated by a very small distance, and the electric field between the plates is E is equal to Q by A epsilon 0. The electric field is uniform. Electric potential between the plates having separation D, it is given by V is equal to ED, that is QD by E into D. E formula is given, Q by A epsilon 0, just that into D, that is all. You will get the formula for V. So the capacitance of the capacitor, what formula we can finally reach? C is equal to Q by V. Q by, for V you put QD by A epsilon 0 in the denominator. So the bottommost term will go up. Okay, so here it goes up, Q and Q gets cancelled. So you will get E0A by D. Fine. So this is very easy for you. Physics is a very really interesting subject, and if you understand the concepts well, then you can do it easily for the examination. First of all, what you have to do is understand the concept deeply, learn all the formulas, and whenever what formula is required to be applied, that you should be able to identify the formula. That is the main purpose, and you have to learn to find out the formulas very quickly. Okay, now next, capacitor connected with a battery. Okay, how will you connect a capacitor with a battery? Here plus Q and minus Q, area A, and here plus, and here this is minus, and this is the distance between them. Okay, with that we are coming to an end of this session. I hope you enjoyed this session, and please do like, share and subscribe to my video. Thanks for watching it, and watch for more videos. And as always I say, please do like, share and support my channel. Thank you.